With the development and growing applications of technology in our daily life, our dependence on machines and electronic equipment has grown manyfold in every aspect of life. However, mechanical failure in these devices poses a huge problem as it disrupts life. In case of failure, the only option is to repair or sometimes replace the item. Repairs using external interference shortens the life of electronic equipment and increases maintenance costs exponentially. Such repairs are difficult in cases such as spacecraft, where intervention also involves danger to human life. Keeping these needs in mind, researchers from the Indian Institute of Science, Education and Research, Kolkata, and IIT Kharagpur have developed piezoelectric molecular crystals that repair themselves from mechanical damages without need for any external intervention. This is developed by a team of researchers led by Professor C. Malla Reddy from the Department of Chemical Sciences and Professor Nirmalya Ghosh from the Bio-Optics and Nanophotonics Lab at IISER, Kolkata.
It is very difficult to achieve materials which repair themselves, particularly when they are not very soft. So here in our work, what we try to do is to develop some fundamentals to make solid materials heal themselves.
So the piezoelectric property is a property of certain kind of materials. When you apply pressure or if they are subjected to mechanical stress, so they generate electricity. So at the heart of this effect is the change in the crystalline structure, that is permanent change in the crystalline structure, which results in change in the polarization. So this macroscopic polarization leads to generation of the surface charges, and which is actually at the heart of this self-healing mechanism that has been observed by Professor Malla Reddy and his students.
Piezoelectric materials generate electricity when they undergo mechanical stress. The piezoelectric molecules developed by the scientists are called bipyrazole organic crystals. These molecular solids have the unique ability to generate an electric charge when they undergo a mechanical impact, which essentially means that fragments broken off from the damaged part are pulled back towards each other and interact as before. In this way, mechanical damage is automatically repaired within milliseconds and with crystallographic precision without any external interference. Professor Bhanu Bhushan Khatua and Dr. Sumant Karan have studied the performance of the new materials for fabricating mechanical energy harvesting devices. The new material could be used in high-end microchips, high-precision mechanical sensors, and micro-robotics. In the future, these materials can be used in developing smart gadgets that will be able to repair cracks and scratches on their own.
These piezoelectric molecular crystals, due to the unique property of generating electrical charges on mechanical impact, the broken pieces can self-propel and rejoin in a blink of an eye and repair themselves so precisely that they become indistinguishable from the undisturbed materials.
The research, which is supported by the Science and Engineering Research Board of the Department of Science and Technology, have recently been published in the journal Science. This is a unique indigenous invention that can be of great help in many applications, especially in the space sector. This discovery also has the ability to make the repair and maintenance of electronic equipment cost-effective.